Hi guys, I've been fielding some questions about reference angles, so I kind of feel like the best way to explain it is through interpretive dance. So here we go. So, I tripped over a hose. Okay, I want you to imagine the unit circle or a circle in the coordinate plane. If we were to rotate one full rotation, that would be pi over 2, 360 degrees, pi over 2. If we were to do half a rotation, that would be pi. If we were to do a quarter of a rotation, that would be half of pi, or pi over 2. So far, so good? Okay, now let's go around, let's think about pi over 4 and reference angles. If I'm looking at 1 pi over 4, the reference angle as I drop my perpendicular is pi over 4. 2 pi over 4 is 1/2. 3 pi over 4, my reference angle is pi over 4. 4 pi over 4, pi. 5 pi over 4, my reference angle is pi over 4. 6 pi over 4, or 3 pi over 2. 7 pi over 4, reference angle is pi over 4. 8 pi over 4 is pi over 2. Now I could keep going to 9 pi over 4, 10 pi over 4, 11 pi over 4, 12 pi over 4. Notice 12 pi over 4 is 3 pi, and it's coterminal with pi. I can do this with pi over 6s. 1 pi over 6, 2 pi over 6 or pi over 3, 3 pi over 6 or pi over 2, 4 pi over 6 or 3 pi over 2, 5 pi over 6, almost pi, pi. 7 pi over 6, 8 pi over 6 or 4 pi over 3, 9 pi over 6 or 3 pi over 2, 10 pi over 6 or 5 pi over 3, and 11 pi over 6, or that's just 11 pi over 6. Notice the reference angle is pi over 6. And then 12 pi over 6, also known as 2 pi. Now, here's kind of the interesting thing. When I go through my pi over 6s, the ones that do not reduce, 1 pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Notice all of those, the reference angle was pi over 6. And if I do my pi over 3s, my 1 pi over 3, my 2 pi over 3, my 4 pi over 3, and my 5 pi over 3, notice that all of those have a reference angle of, you guessed it, pi over 3. Okay, hopefully that helps to explain the radians and reference angles. I feel ridiculous. I love you guys. I wish we were together. Bye.